Question 26 asks you determine the amount of heat given off when 1.626 times 10 to the fourth power gram of NO2 are produced. According to this balanced equation, 2NO react with O2 produce 2NO2. This thermochemical equation tells you the enthalpy change is negative 114.6 kilojoule per mole, according to this balanced equation. Then also, if 1.26 times 10 to the fourth power gram of NO2 are produced, then what is total heat will be released? Okay. Since this is mass, right? Gram is mass, so we need to convert to mole first. Then use this amount, because this amount is every 2 mole. Every 2 mole NO2 will produce this amount of energy. Okay, so anyway, we need to convert this into mole first. How to convert the mass into mole? Mass divided by molar mass, right? I wrote in that corner many times. I don't want to write again today. So 1 more NO2. How many gram? You need to use a periodic table. N, periodic table tell you N, the mass is 14. O is 16, but you have 2 O there, right? Mass divided by molar mass, we get more. Then, according to this thermochemical equation, every 2 more NO2 produce this amount of energy or release this amount of heat. So you need to write 2 in denominator, because this is every 2 more release this amount of energy. All right, so more NO2 cancelled, left over total heat. Okay. Use a calculator, you can easily get the number is negative 1.57 times 10 to the fourth power kilojoule of heat will be released. Okay. Are you okay for this? Okay. If you're okay with this, then take a look at next 35. Question 35 asks you calculate the amount of heat liberate is released from 366 gram of mercury at 77 degrees Celsius cools to 4 degrees Celsius. Ask you how much heat will be released. Okay. So a hot mercury cools down. This is a physical process, no chemical reaction. Iron bar cools down, or here mercury cools down, the same. You need to realize you need to use this formula: mass times specific heat times temperature change, right? Mass here tell you 366 around. Temperature change, final minus initial. So these two tell you. Then we need to find S, specific heat, right? Then we can calculate it. specific heat during the quiz or test, I will provide you a table. So in the PowerPoint slide, we have this table, right? So we can find a specific heat for mercury. Just plug in the number 366 gram. For mercury is 0.444 joule per gram per Celsius degree. Okay. Again, we find this in a table provided. Then temperature change, always final minus initial. Okay. And the delta always final value minus initial value. Okay. Okay, use a calculator. Oh, sorry, mercury is not 1.144, it's 0.139. Aluminum 0.144 maybe. Anyway, I will provide you a table. Okay. This will be negative 3306.8 joule. If converted to joule, you can use convert to kilojoule, move 3 decimal place, becomes 3.3. Since the non-value tell you or in 3 significant figure, so we keep 3 significant figure, right? 3.31, because it used to be 3.36, 3.306, and this one is 6, greater than 5, we run up to 1. Okay, keep 3 significant figure.
Point after 3.
Huh? This is the 1.
The top one, though.
This?
The top one.
Top 1?
Yeah.
3306.8. This is joule. If we keep 3 significant figure, the last one is 0, right? But the next one is 6, greater than 5. That's why we run up, 0 becomes 1. 3.31 kilojoule. From joule to kilojoule, you move back 3 decimal place. They're okay for this. Okay. If you're okay for this one, then go to the next. Okay. Next one, let's take a look. 57. Question 57. Ask you from the standard enthalpy formation, calculate the reaction enthalpy change for this reaction CH6 HW liquid react with 9 oxygen gas, produce 6 carbon dioxide and 6 liquid water. As you calculate standard enthalpy of the reaction, right? So chemical reaction, to calculate the standard enthalpy, right? Standard enthalpy of this reaction. The general formula is total standard enthalpy formation from products, right? Products, you have 6 more carbon dioxide and 6 more liquid water. These 2 products, right? So total standard enthalpy formation from products. This number comes from the balanced equation. Okay. Then minus total standard enthalpy formation from reactants. 1 more C6 H2O, 9 more oxygen gas. No number means 1, right? So delta HF naught of C6 H2O plus 9 more oxygen gas. These two are reactants. Products minus reactants, right? Then just use a table. So during the quiz or test, I will provide you a table. So find the standard enthalpy formation for each substance listed here. 57. Okay, carbon dioxide is negative 393.5. 6 times carbon dioxide standard enthalpy formation is negative 393.5. Water listed in the table, you have liquid water and gas water. Be careful here, it's liquid water. So you need to use the value from liquid water. Liquid water is negative 285.8. This product. Then reactant, CH6 HW. This value standard enthalpy formation negative 151.9. Oxygen gas as free element in its most stable state. This is 0. Right. Then use calculator. You can easily get the final answer will be negative 3923.9 kilojoule. Okay. Formula. Total standard enthalpy formation for products. You list all products together with their coefficient. Minus total standard enthalpy formation from reactants. Don't forget coefficient. If no number from the balance equation, this means 1. Okay. Then find standard enthalpy formation for each species from a table provided. During the class, PowerPoint, we have one slide that lists the table, right? Then find a value, then use calculator. Okay. During the quiz, you need to show work. Step 1, step 2, step 3. If you choose these two correct, unfortunately, last step not correct, you get the most. Don't worry. Okay. But again, if you didn't show work here correctly, you just give a correct answer, not related to this number. No credit. You cannot correct your answer if no work here. Okay. Just remind everybody, you need to answer my question, not answer your own question. This is not a pure math. You cannot correct a pure math. It's based on this chemistry question. Okay. I asked. Are you okay with this? I can tell you we will have similar in the quiz and the test. Similar question.
What did you put next to H2O?
Next to this?
No, in the products.
Product.
Next to H2O.
S CO2 or this?
Yeah.
Oh, this air. Product, this air means liquid. G means gas. If you take a look at the table provided you, water, one is liquid, air, one is gas, listed as G. So you need to use the value listed as air, water. Okay. So this is gas, water, liquid water are different state. They have different value of standard enthalpy formation. Any other question? If no, okay, we have another. Okay, 6-3. Question 6-3. Question 63. From the following heat of combustion, so actually here you 3 reactions with their standard enthalpy reaction. As you calculate the 4th reaction's enthalpy change. Okay, so reaction 1, CH3OH react with oxygen, produce carbon dioxide and liquid water. Reaction 1's enthalpy change is negative 726.4 kilojoule more. Okay. Reaction 2 is carbon, which is graphite. React with oxygen gas, produce carbon dioxide. Enthalpy change is negative 393.5 unit cell kilojoule per mole. Reaction 3, the hydrogen gas react with oxygen gas, produce liquid water, because here liquid water, they must be same. This reaction's enthalpy change is negative 285.8 unit cell kilojoule per mole. So also use these three reactions enthalpy change, calculate reaction 4's enthalpy change, which is carbon react with hydrogen gas and oxygen gas, produce CH3OH. This reaction 4's enthalpy change is synthesize this compound from its element carbon, hydrogen, oxygen, right? Carbon, hydrogen, oxygen. So this reaction is synthesize this compound from its element. So this is the standard enthalpy formation of this compound. So also you calculate this. Okay. The strategy is, how can we build up this equation 4 from equation 1, 2, and 3? This is a strategy. Just take a look what we need in the equation 4. So we want, right? We want one carbon. Then equation 2, we have one carbon there. Equation 2, we have one carbon. We get it. Then we need 2 hydrogen. Which one have hydrogen? Equation 3. But the equation 3 only one hydrogen, right? Then multiply by 2. This equation you multiply by 2, then delta H also multiply by 2, right? This is a principle we learned. Okay. So we multiply 2 of equation 3, we get 2 hydrogen. Okay. Then we need 1/2 of oxygen. Oh, you find every equation have oxygen there, right? Equation 2, equation 3 both have oxygen. So you can put outside some oxygen there. Last one. You may have a question, but definitely we have oxygen there. Last one is CH3OH as product. Which one has CH3OH? Equation 1, but equation 1, CH3OH is a reactant. Then we just minus equation 1. Minus equation 1 is a minus this, right? So we'll move to the right side as a product. Minus equation 1, we get this CH3OH in the right side. Is this equal to the equation you want, equation 4? You may have a question, even though we get 1 carbon from equation 2, we get 2 hydrogen from equation 3 times 2, and we get CH3OH from minus equation 1. But all these equations provide oxygen, so this is 1 not sure, but definitely helps out this year. Another question is, these equations provide carbon dioxide and water. And the target reaction, no water there, right? No carbon dioxide. So this is it. You may have this question. Is this really give you equation 4? If you're not sure, you can work on the scratch paper to confirm this is. So the rest here is on the scratch paper. Use this formula, we just assembled on the left side first. So equation 2, left side is C plus O2, right? Equation 2, left side. Equation 3 times 2, left side. 2 hydrogen. 2 times 1/2 is 1, right? Oxygen. Then minus equation 1, minus CH3OH, minus 3/2 O2. We finish this formula on the left side, right? Now we use this formula on the right side. Right side equation 2, CO2. Right side 2 equation 3, 2 water. Right. Then minus equation 1, still right side. So minus CO2 minus 2 water. Right, you find right side carbon dioxide gone. Water also cancer. Nothing left the right side. Left side, 1 water, 2 water. No, so oxygen. 2 oxygen minus 3/2, or 1/2 left, right? Carbon, only 1 carbon, nothing can combine. So carbon, 2 oxygen, also nothing can combine. Then oxygen is 1/2 of oxygen. 1 minus 3/2, 1/2. Then minus CH3OH. Right side, nothing left. Chemical equation, normally no minus. Then we move this to the right side. Right, initial right side, nothing left. We move to the right side. Become this. Is this the equation we want? Yes. The equation we want is exactly. Okay, this means we confirmed from this formula, we can build up equation 4. Again, this, you work in the scratch paper, you don't have to show me. If you show me, it's okay, but you need to show crap work. But you need to show me this for sure. Otherwise, you cannot get to the next step. From this formula, equation 2, this is delta H2. Right? Equation 3, delta H3. Equation 1, delta H1. Equal to equation 4, then delta H4. Right? Delta H4 is the standard enthalpy formation of this compound. Right? So we just plug in the number. Now, delta H4 is the one you want to figure out. Just plug in the number. Delta H2 number is negative 393.5. Delta H3 is negative 285.8. Delta H1 is negative, be careful, the minus negative 76.4. Use calculator, you can easily get This number is negative 238.7. More. Okay. Are you okay for this?